Hello everyone, welcome to the RCNP course. Today we are going to introduce the link aggregation principle. And firstly, let's take an overview of link aggregation together. In the case of SDP, the redundant link of the device is blocked and the link reliability is improved, but the link bandwidth is wasted. Link aggregation is the aggregation of multiple physical ports together to form a logical port. Packets passing through the logical interface will be load shared among the member ports of the aggregated ports, and the load sharing is dependent on the administrator's configuration. And let's see the background of link aggregation. In which case, maybe the link aggregation is necessary. In the following scenarios, in order to meet the data interaction between different servers, the core switches must have higher bandwidth between them and need to have redundant backup of the link. So to satisfy this requirement, the number of physical links between core switches can usually be increased. So in this way, we can improve the link bandwidth. But if we maybe only add a physical link between these two switches, for example, like this, while we should use SDP to prevent the layer 2 loop between these two switches. And once we use SDP, the redundant link between cores will be blocked, which can achieve redundant backup of links, but fails to achieve the purpose of improving link bandwidth. Because even you have two physical links between these two core switches, but there is only one link that is active, and the bandwidth is unchanged actually. So what we can do? Let's see the solution. Link aggregation, also known as aggregated port, is a physical boundary of multiple ports of a switch with the same characteristics into a single logical port. And the aggregation standard we use is IEEE 802.3 AD. And by using link aggregation, we can extend the link bandwidth. We can have automatically redundancy backup of the link and multi-node traffic balancing on aggregated links. Once using link aggregation, we can bind these two physical links into one logical link, or we can bind the physical ports into one logical port, which is the aggregated port. In this way, we don't need to use SDP between these two switches, and no ports will be blocked. So the bandwidth has increased and the redundancy has been improved, right? Okay, this is about the overview of link aggregation. And then let's see the working principle of link aggregation. The first link aggregation mode is the static aggregation. No protocol negotiation is enabled on each member port in the aggregation group. It is port state is entirely based on manual assignments that take effect directly. It requires user commands to create and delete static link aggregation groups. So from here, we know that the link aggregation mode, which is static, represents that we should manually configure it, and it's fixed. Okay, the commands we use directly affect the port state of the aggregation group, right? And there's no protocols running on both ends, so there's no packets exchanging between these two switches to control maybe the aggregate group between these two switches. Okay, this is a static aggregation. And the next is a dynamic. If we use a dynamic link aggregation, we should use a protocol. The protocol is called LACP. LCP stands for Link Aggregation Control Protocol. it is enabled on each member port in the aggregation group and interacts with the peer device. Its port state is automatically maintained through this protocol, and it requires users' commands to create, delete static link aggregation groups. So, which is similar to the static aggregation design, we should use commands to manually configure the aggregation groups. But if we use the dynamic aggregation between these two switches, there will be a protocol which is called RCNP. And the function of RCNP is used to manage the aggregate ports on both switches, to monitor the running status of the end and to maintain the state of each port. Okay, this is about the static aggregation and dynamic aggregation modes. And if we use the dynamic aggregation, since the port's state is automatically maintained, means that they should negotiate, right? They should negotiate with each other. And to negotiate with each other, they should know the status of each other. They should know the characteristics of each other. So we should have a message to carry this information, carry these parameters. And to send the packets or to send the messages, we should know the rule of the switch. So let's see. If we use a dynamic aggregation, the rule or the mode of the switch could be active or passive. If it's active, means the ports will initiate RCNP message negotiation. Means that if this active port, this port will generate and will send the RCNP message to the neighbor. While if the mode is passive, means this port will only respond to incoming RCNP packets. Means it will not generate the RCNP packet, but after receiving the RCNP packet from the neighbor, it will respond. It will respond to the neighbor. Okay, this is about the mode of link aggregation. And you should know that both layer 2 and layer 3 ports of the switch support port aggregation. And both static and dynamic aggregation modes are supported. So the aggregation port could be a layer 2 port or a layer 3 port. Okay. And later we are going to show you how to set the port as a layer 2 or layer 3 port. We will show you the commands. But before that, let's go on to see the traffic balance in the link aggregation group. Traffic balancing, they distribute traffic evenly across the AP's member links. For example, in this case, we have 4 member links in this aggregate ports, right? And all the traffic should go through these 4 ports. But how can we determine, for example, how can we determine the modes of the load balancing, or what are the load balancing modes we could use? Let's see it. The traffic balancing methods have the source MAC address, destination MAC address, source IP, destination IP, source MAC and destination MAC, or source IP and destination IP. Here, the method refers to the way how can we distinguish these packets. Okay? Because to load balance the package, we should distinguish them into different types and then forward them via different links. So the method to distinguish these packets is called traffic balancing method. For example, if you choose the source MAC address, so we can distinguish these packets to different types based on the source MAC of this packet. Or destination IP means that we can distinguish the packets based on the destination IP address of the packet. Okay. And the flow balancing method can be different for different devices. For example, here, on both ends of the link aggregation, you can see, for example, on the upper switch, the method we use is a destination MAC traffic assignment. And on the other switch, the method we use is a source MAC traffic assignment. So on different devices, the method could be different. Okay, and if you want to check the load balancing method on a specific device, you can use the command show aggregate port load balance. So you can see, for example, load balance is source IP and destination IP. It's a method we're using on this device, which you are checking. Okay, this is the working principle of the link aggregation. And next, let's see the configuration of it. First step is to create the aggregate port, interface aggregate port, followed with a number. For example, interface aggregate port 1, interface aggregate port 2. Okay, and then configure the Ethernet static AP member ports. For example, port group 1. This is used, or this is configured on one specific interface. For example, this is configured on one specific interface because the command is used at the interface configuration view. For example, port group 1, port group 2. It depends on which aggregate port you have created. For example, interface aggregate port 1, the AP number here is 1. So you can use port group 1, means we have added this physical port into the AP1. And then configure layer 3 aggregation interface. Because by default, the aggregate port is a layer 2 interface. By using command no switch port, so we can change it to be a layer 3 port. And then configure the traffic balancing mode. Aggregate port load balance, you can choose the method you like. DST MAC is a destination MAC and source MAC, or source destination MAC for IPs, destination IP, source IP, or source and destination IP. Right? It depends on the scanner wheel where you use the link aggregation. After knowing these commands, next let's see an example. Now, between SW1 and SW2, we are creating aggregate ports. So here you can see link interface range gigabit Ethernet 01 to 2. So we are configuring both G01 and G02 at the same time. Port group 1 means both of them belongs to the aggregate port 1. And here, maybe you will get confused because why do we not create the aggregate port 1 in advance? Because even you didn't create the aggregate port 1, but after using these commands, the system itself can automatically create an aggregate port. Okay, and then interface aggregate port 1 switch mode port trunk. Switch port mode trunk to configure the aggregate port to be a trunk port. And then here the load balance mode, we choose, let's see it, aggregate port load balance as source and destination MAC. Okay, and the configuration of the other end is the same. Okay, this is a configuration of the static link aggregation. And the next, let's see the configuration of the dynamic. Creating Ethernet AP ports aggregation groups works in static aggregation mode by default. So interface aggregate ports, for example, interface aggregate port 1, and then configure Ethernet LCP member ports. Port group, the key number, right? And then modes, we can choose it to be a active or a passive mode. But here you should know that on both ends of the link aggregation, at least one of them should be active. Okay. And then configure the system priority of LCP. LCP system priority, and you can set the value at this point. And configure the priority of the LCP member ports, LCP port priority here. And configure layer 3 aggregation interfaces. No switch port. No switch port means this is a layer 3 port. And configure the traffic balancing mode. It's the same as what we just did. Okay. After knowing this command, let's see another example. First, the interface range, gigabit Ethernet 0, 1, 2, 3, port group 1, mode active. Pay attention here, the mode we use is active. And from here, we can know what we're using is the LCP mode. And interface aggregate port 1, switch port mode trunk, and aggregate port load balance, source and destination MAC. Okay. And to verify the result, we can use a command show aggregate port load balance. On switch A, what we use is a source MAC, and on switch B, what we use is a destination MAC. And check the correspondence of AP ports and member ports show aggregate port summary. So you can see that the aggregate port is AG3, and the member port is G11, G12, right? And show LCP summary. You can see the LCP link state. Okay, and for configuring the link aggregation, here are some notes. Let's see it. The AP number ports must have the same rate in 4 duplex mode. Must belong to the same VLAN. The transmission medium used should be the same. So the rate should be the same, and the VLAN should be the same, except that the transmission medium should be the same. Only in this way we can maybe put them into the same aggregate ports. By default, aggregate ports created is a layer 2 AP port. And if the aggregate port is a layer 2 port, so you can only add the layer 2 physical ports into the layer 2 AP port. And for layer 3, it's the same. Layer 3 ports can only be added to layer 3 AP ports. And for the port security, it cannot be set for the AP port. When adding a port to a non-existent AP port, the AP port will be created automatically. Okay, we just mentioned it, right? And when a port is added to the AP port, the port's attributes will be replaced by those of the AP port, and no configuration can be performed on the port until the ports exit the AP ports. And when a port is removed from an AP port, the port's properties. And when a port is removed from an AP port, the port's properties are restored before it was added to the AP ports. Okay, so during the configuration of the link aggregation, you should know the notes here. And at last, about the link aggregation, let's see the test. When dynamic LCP port aggregation is configured between 2 switches and the aggregation mode at both ends is passive mode, the aggregation can be successful. Actually, I have just mentioned it. We said that the link aggregation mode, if it's dynamic, for both ends of link aggregation, at least one end should be active. Because if both ends are passive, no port will generate the LCP packet. So they will not start to negotiate, right? It will cause that the link aggregation cannot establish, okay? So the link aggregation cannot be successful. The statement here is false. We choose B. And the next, which of the following conditions may cause port aggregation to fail? A, 2 member ports are optical and electrical ports. Actually, it will cause port aggregation to fail because the port type we use is different. B, 2 members ports are gigabit optical port and 10 gigabit optical ports respectively. Actually, it will cause the failure because the rate is different. C, when during the layer 2 aggregation, the 2 member ports belong to different VLANs. Of course, it will cause the failure because they are not in the same VLAN. And D, both member ports are gigabit 4 dumplets, electrical ports, means these two member ports are the same, right? So the aggregation will succeed. So here we choose A, B, and C. Okay, so for the link aggregation, let's make a summary together. Between core switches, the bandwidth between devices can be increased by port aggregation while providing redundant backup links. Port aggregation is divided into static and dynamic modes. Each mode can complete the aggregation of layer 2 ports and layer 3 ports. Okay, so that's all for this part about link aggregation. Thank you for your listening.